Influx and its software does something truly magical. It transforms injection molding from high pressure to a low pressure, and that opens a world of possibilities. We're Influx. We may seem new to the industry, but our expertise runs deep. We are transforming the future of injection molding with our box and software that unlocks virtually any machine, material, or mold. What does this mean for you? First, it takes you from high-pressure conventional molding to innovative low-constant pressure molding, letting you produce higher quality parts, reduce costs, and lower capital. Second, it puts you on the journey to autonomous molding, recognizing issues that could impact the outcome of your product and correcting them in real time, so you can deliver consistent products without the need for manual operator adjustments. Finally, it puts a solution for sustainability at your fingertips. Immediately run more sustainable materials with less energy, wear, and waste. All this and so much more. Let's change the way the world molds. We are Influx, innovators transforming the future of plastic injection molding.
Welcome everyone. Thank you for joining us for the second installation of our Fearless Innovation series. We're gonna get started here in just a minute. Before we do, we just have a couple of housekeeping items. We're gonna have a Q&A later, so if you wanna save your questions for then, go ahead and do that. But we also have a live chat with experts standing by. So if you have a question you wanna ask now, feel free to drop it in the chat. And just to make sure that the chat is working properly, if everyone watching right now, as we introduce ourselves, could just drop where you're tuning in from into the chat. One, we can see that the chat is working, and two, we can just see where people are joining us from, so please feel free to do that now. My name is Ethan Stiefel. I'm a senior manager in R&D here at Influx, where we are fearless innovators transforming the way that the world molds. And in that spirit of innovation, I'm so excited to announce our partnership with JSW, Japan Steelworks America. JSW is one of the only Japanese manufacturers that makes everything in-house. So you guys have 100% control of your quality. And that quality is just one of the many reasons why Influx is so excited to partner in innovation with JSW. With me here is Dale Bartholomew. Thanks for joining us, Dale. I'm gonna let Dale tell us a little bit more about JSW.
Thanks, Ethan. Appreciate it. Hey, everyone. My name is Dale Bartholomew, and I'm the National Technical Manager for Japan Steelworks America. And we are very excited to be here with Influx. As our name says, we are a steel manufacturing company. Japan Steelworks has been in existence since the early 1900s, focusing on our core business of steel. As the plastics industry was being developed early on in the 1950s and 60s, JSW recognized that as an emerging technology, so we got involved. We utilized our manufacturing experience from our many years of the steel industry, and we were able to apply that to building injection molding equipment, and we have since been focused on that. In the 1980s, we developed the all-electric machines. Instead of having the hydraulic machines where you've got the contamination of the hydraulic oil, it wasn't a very clean process. But in Japan, green technologies have always been very popular because you've got the shortage of space, the energy usage. You know, we try to reduce everything. So JSW has been focused on reducing that carbon footprint, basically. So we developed the all-electric machines in the early 80s, and we were able to build off of that technology and gain all of that experience.
So how did JSW find and partner with Influx?
Okay, good question, Ethan. Yeah, we were actually at a trade show, and we had been approached by a couple of our customers that were interested in the technology. We didn't know much about it. I remember reading years ago when Procter & Gamble was first developing the Influx process. The information at that time was very vague, but it always struck us as kind of, you know, as a curious thing to look into. After these customers approached us, we happened to be at a trade show. Influx had a booth on the other side of the hall that we took a walk over and started talking, and it just has grown from there. And it's one of the most innovative technologies that we've seen come along in the industry, and it's very exciting to be a part of it.
That's right, Dale. We are innovators trying to change injection molding. And in the industry, one of the most important items for innovation today and moving forward is sustainability. And the all-electric presses that JSW has to offer is a great partnership in that space. And we actually have a JSW press in our Innovation and Education Center, which is where we're going to show you the demo here in just a little bit. That press that we have that's going to highlight is a state-of-the-art packaging press. It's JSW's J350 ADS 460H US, which stands for Ultra Spec, correct?
Yeah.
Why don't you tell us a little bit more about that machine?
Okay, what that is, that may sound like a lot of numbers and may be confusing to some people, but the J350 ADS, that's a 350 metric ton injection molding machine. So there's 350 metric tons of force that keep the clamp closed on that machine. The 460H is just the designation or the size of the injection unit, and the US means ultra spec. So basically that is JSW's race car, and that's what we have in your plant because it's designed to focus on the packaging industry. And packaging is something that is it's a one-use type of product. So having the sustainability of that type of product is what we really need to focus on. And so we built this machine specifically for the packaging machine. We have a whole lineup of general purpose presses, but this one particular is focused on speed and repeatability and reliability. That's what JSW is known for. And by partnering with the Influx, it has given us a lot of the it has solved a lot of the challenges that we encounter every day with our customers.
And that really is a state-of-the-art machine, and we're going to get to see it live in action in this demo. Before we dive into the demo and the details and what we're going to see, what are some of the key features of the Influx technology that excites you in JSW?
Okay, so this is where the Influx system helps us as a molding machine supplier, where the injection motor specifically, if you think about servo motors, they're designed to run at a certain speed to a certain position. And during the injection process, as the mold fills up with plastic, you're meeting resistance, which is basically stalling that motor. So we have developed our motor specifically for that function, to be able to withstand that stalling and dissipate the heat. Because what happens when you stall a motor, it generates thermal heat, which is going to create and thermal overload, which is going to give you alarm. So anyone who has run injection molding presses over the years has encountered those alarms, I'm sure of it. We've done a lot of work with all of our experience of building all electric presses since the 1980s. And by utilizing Influx, it helps alleviate that, because the parts pack as they fill, and it eliminates that having to hold that motor in that stalled state for so long to pack the parts out. It really takes away a lot of the issues, because not only does that create a load and strain on the machine, but it also affects the part quality as well. And by utilizing Influx, it stabilizes that.
Yeah, absolutely. And that pack as it fills feature has a couple benefits. First, it really just comes down to the low pressure of our system, whereas conventionally, like you said, the servo motor's built to go to a set position at a set speed. When you're doing that, plastic pressure is going to rise, it's going to spike, it's going to get really high before you transfer, and then you're left in the second half trying to pack that part out. And with Influx, because we're at a low constant pressure, we're actually packing the part as it fills. The best analogy we can use for that is a hose in the wintertime. So even though it's freezing outside, as long as you have some movement, constant flow of that water going through the hose or the pipe or whatever, it won't freeze off. And Influx is very much the same way. We're at low constant pressure, but because of our melt pressure transducer giving us constant feedback, it allows us to maintain that flow no matter what, that constant plastic pressure, which alleviates the maximum pressure that you need to fill the part, and alleviates having this long second portion of pack and hold. So we're talking lower pressure, you mentioned lower or better part quality because less stress, as well as faster cycle times. And all of that can be done with the Influx system. Is there anything else that you're excited about?
Yeah, the ability of the Influx, it not only because you have, and it's not only the pack and hold phase of the injection molding process, but there's also each time that machine, when you're trying to inject at those high rates of speeds in a conventional molding process, every little turn and restriction in that runner system creates more shear heat to the material. So you're degrading the material as you're injecting in there. But by utilizing the Influx system, it greatly diminishes that effect. Yep. So it benefits us overall, and we get to utilize a reduced tonnage as well. So there's many different phases of it where it's just a good fit.
Yeah. And one of the things I love about this partnership so much is we mentioned lower tonnage, we mentioned lower pressures overall, lower heats, we mentioned that. All of those things together are not just good for the part itself, it's also good when you're considering sustainability. Yeah. Lower energy on the clamp, lower energy in the injection unit, less heat that we need in the material because we don't overstress and overshear or have such high pressures. We're reducing all of that. And that's on top of, you take Influx that does that as a technology, and then you take the JSW press, which in it of itself is designed to reduce energy as an all-electric press. So you put those two things together, and the sustainability benefits both for a customer and for the environment and globally are astronomical. We actually have a little bonus demo for you. We're not going to show you anything, but we've done a little bit of experiments ahead of time of Influx on the JSW press. And we did experiment in our IEC versus other machines. And the JSW press with Influx on it, compared to hydraulic presses or hybrid presses, had an over 36% energy reduction per part made. So we actually have that graphic here we're going to show you. This is an incredible demo that we did, a little experiment just to show truly how powerful this partnership can be when we're looking at things like energy reduction and sustainability.
Yeah, the JSW presses have always been very energy efficient because of the way it is in Japan, where energy costs are very high. So we reduce that energy usage to lower the cost for the manufacturers. And by utilizing some of the technology we've developed is we have regeneration circuits, whereas motors, as the motor is running full speed and comes to a braking or a stopping point, we take that unused energy and we store it, and it's utilized in other facets of the injection molding process. So we're constantly reutilizing the energy that's being consumed and applying it to different segments. So it gives us that benefit of being just so much more energy efficient, and combine that with the Influx where we're not operating at these crazy high pressures and speeds. And the funny thing is that, you know, when you hear something like, you know, a low, slow, constant pressure, it automatically creates an image that, oh, my cycle is going to be longer. And that is not the case. We've got this machine back here. We had that running at 32 cavities, and we were running it at 4.7 second cycles without any problem whatsoever. It was able to do that consistently.
Yeah, and that comes from the benefit of a state-of-the-art all-electric packaging machine on top of Influx's ability to reduce cycle time. You pair those two things together. So now not only we're looking at better quality parts, faster, but still reducing the amount of energy used to make those parts. And that is what we're talking about, partnering in innovation, both just generally in injection molding, but specifically with the aim of sustainability in the industry.
Yeah, utilizing the auto viscosity adjust, we're going to have, we have some exaggerated examples we're going to be highlighting in our demonstration that is going to show you the effects of the changes in viscosity and how the Influx system is able to compensate for those, which contributes to the sustainability.
Yeah, absolutely. We have our JSW press. We're going to be highlighting in this demo a couple of different things. One of them, as you just mentioned, is our auto viscosity adjust feature, which basically, using our constant pressure, it looks at the viscosity changes in the material and automatically adapts to those. So not only are we adapting to the pressures in the machine and reducing those, reducing energy and cost there, we're also adapting to the material. So Influx allows the material to shift enormously. So like you mentioned, it's an exaggerated example, but one of the difficult things about sustainable materials is they often differ in change and the viscosity is not consistent. So we have to use all these very high cost engineered resin materials, virgin materials, to get that consistency. The conventional process does not care about what's happening to the material. It runs its settings, period. So if there's a change in viscosity, a change in melt density, anything, it's going to create bad parts when that change comes. And what auto viscosity adjust does is it adapts real time. We truly are on a journey to autonomous molding, and that's the next step of that. And that demo is going to show that. The other thing it's going to show is block cavities. You want to talk just a little bit about that before we get down to the demo?
Yeah, in a conventional process, if you have, like, for an example, we're running a 32 cavity mold in the back. What we're going to be doing, and this is one of those exaggerated examples, is we're going to actually block off 8 of those cavities. And anyone that knows injection molding knows if you block off those cavities, as you're injecting all of that material into that mold, that excess material is going to want to go somewhere. And with the influx process, it's able to compensate for that real time because utilizing the melt pressure technology.
Correct.
And that's a great thing for our process.
That's exactly right. Influx cares not only what happens in the mold, but also what happens to the material. It cares about both. And we are so excited for JSW to join us on this leg of our journey to autonomous molding. That's what we're going to show here. So we're actually going to take it away to Mitch Wild and Yuki Mikamoto out in our IEC. They're going to walk through this incredible demo with you. Mitch, take it away.
Thank you very much, Ethan and Dale. I'm Mitch from Influx, and this is Yuki from JSW. We're very excited to show you this trifecta of demos we have here today between the JSW packaging machine, the cavity block-off demo from Influx, and the AVA demo from Influx as well, which is auto viscosity adjust. So the first thing I want to talk about is a little bit in how you set up an Influx process. And broken down is simply a pressure for an amount of time, and then we have a compensation for any cavity pressure or your end of fill. So you could set this up for one step across the entire process, or you could do what we're doing currently where we ramp up to a certain pressure. That's to give a slower velocity through the beginning and then steady off it to a set pressure. Now with Influx, you could set all kinds of complex graph geometries and set points, but you don't need to. You could have this go any way you want. You could write your name with a set point in it. Granted, I don't think that would make a good part. So one of the first things I want to highlight here is this variable velocity. Conventional molding, you'll always recognize your variable pressure. And it's typically a very high variable pressure. What you're going to see here is variable in the velocity to the part geometry. I'm going to grab a part here. One of the things with Influx is the part geometry dictates the velocity. So you can see here we're entering through a center gate where this graphic of the ship is. You can see us entering here, building up melt pressure, coming through the gate, steadily filling through these fins. Then as pressure starts to get created by venting, right? You're not able to get the gas out, just thinner wall here. You start to create pressure and we drop velocity because there's more pressure in here. Then we backfill. Then the material then speeds up because it's expanding through the seal. And then we once again, towards the end of fill, which is around these lips, we reduce pressure. Now we do this with a little bit of compensation with our PFA. So you can see how the very complex fill pattern, Influx adjusts to it just because we're controlling to a pressure. You're controlling to a straight velocity. In these areas where the velocity reduces is actually conventionally where the pressure would rise, which is harder work on your machine, more work for it. It's not sustainable, and it wears on your machine. So the first thing we're going to do for you today to kind of show how this is beneficial, we're going to block off some cavities in this mold. Yuki's going to help me out here. We're going to block off an entire quadrant of this mold and still run the same exact process. And you can go ahead and put it in. Oh, I forgot. So Yuki just kind of helped me out. I totally forgot. We need to grab the weight of these parts. This is the process that we're running, right? This is our validated process. Now what we're going to do, we have the weight. We're going to stop the machine and block off that quadrant. So we're blocking off 8 out of 32 cavities, and we're not going to make any changes. And this thing is not only is it not going to flash, but it's gonna match that weight. Pretty cool stuff. Go ahead, Yuki. So before we actually shoot this, I know some of you are sitting there thinking, well, Mitch, why would I want to just block off an entire quadrant of my mold and reduce my OEE by 25%? Well, you wouldn't want to do that. But what we want to show you is that when you're controlling to a pressure, how it automatically adjusts for changes in your mold, right? So maybe we're blocking cavities in this scenario, but maybe that's similar to when your viscosity changes, right? Or there's wear and tear in your mold. So now if you were doing this conventionally, once again, right, you're controlling a velocity from one position to the next. In that transfer there's a certain amount of material. No matter what, that material is going into your mold, right? Well, not with Influx, because we're going to adjust our actual travel, and Ethan and Dale will talk about that a little bit later, or Ethan more specifically about what our melt travel is. But we're going to compensate our melt travel to the changes in the mold. So go ahead, Yuki, let's shoot it. Okay, so as you can see, no flash on these parts. Not only are they not flashed, we didn't make any adjustments. So we didn't have to do some calculation and figure out how to change our transfer or move our shot size, which we all know ultimately isn't perfect. So no changes. 4 parts, same weight. We just dropped 25% of our cavitation, use the same exact process setup, and yes, we're transferring a little bit later now because our melt travel's taking a little bit longer, but all those compensations are autonomous. And we just mold protected. All good. We have a tight mold protect. And as you can see, we're not blocking cavities the conventional way, so one might have slipped a little bit. It looks like we're all set. Maybe thermal expansion, right guys? Yuki, you take care of it. Yeah. So look at that. Stop, mold protect, check for everything. That's real life scenarios right here. Your mold tech check, make sure there's nothing in the tool, restart it after adjusting a couple positions on the native machine. No process adjustments, even with stops. I mean, how many times does a cavity drool and then ultimately block? You lose cavities. Maybe your tool room doesn't have time to fix the mold right now and you need to run down cavities to get an order out. This is a way you could do it without even thinking about it. All right, so the next thing we're gonna do, we're going to swap our wands of material. We're currently running an 11 melt polypropylene. We're going to move to a 25 melt sustainable resins PCR. So stay tuned, pretty cool stuff. We're going to watch this transition in real time to a completely different MFI material. Awesome stuff. Okay, as we're waiting for this material to transition into our PCR sustainable resin, so Yuki, can you... Yep. So Yuki's turned on our AVA technology, that one touch. You can see we do have it set up. And just touch this here. Oh, I'm already on it. So we're targeting to hit this cavity pressure in 1.8 inches of melt travel, which is a little bit different than just a transfer position. Now travel actually compensates for our check ring seating. So we'll get into that another time. If you guys have any questions about that, put it in chat, because melt travel is one of the great benefits of Influx that doesn't even get talked about much. It's basically automatic compensation for a worn check ring or changing viscosities. So what we're doing is set this up for cavity pressure or end of fill to hit at 1.8 inches of travel or 1 second as a backup, right? So we're at 1 second of time and 1.8 inches of travel roughly. So as this new sustainable material enters in, which is a higher MFI, it's gonna flow a little bit easier. So what we should see as these percentages start to drop, because it'll need less pressure to achieve the same amount of melt travel or the same amount of compression in the mold. So while we're waiting, there is something that I want to talk about with this JSW controller, because this is the most intuitive controller I've ever worked on. I've worked on just about every brand of machine out there, every controller. And what JSW did here, I absolutely love, because first, it's basically app-based looking. It looks like you could download Candy Crush on this thing. Now you can't. I asked and they said no. But it's basically just icons for all your settings, right? Mold setting, molding monitor, with tabs above. You go back to your home screen just like you would on an Android or on an iPhone. You have a screenshot, right? It's just incredibly intuitive. And one nice thing that I like being in between generations where touchscreens are great, but I like soft keys and toggles when I'm actually controlling my clamp unit. So as an older processor, I'm a big fan of physical buttons so that I know what I'm pressing. I get that feedback to know that I press that manual button when something bad's gonna happen. So I absolutely love this controller. Now this machine itself is a beast as well. It's got a very rigid frame. It's able to run at very high speeds, 24:1 stock L to D ratio, L over D ratio. The thing runs at 500 millimeters per second. It's quick, it's fast, it's robust, and the Mold Protect, as you saw from our earlier demo, is incredibly touchy if you want it to be. We had a block cavity on there, and one of the ridges just happened to fall off a bit, and it stopped on a dime. So yes, awesome, yes, we're starting to see the transition now. So you're starting to see, we've already dropped 5% from our original set point, right? If our original set point's 10,000, we're gonna drop 5% of it. Or in this case, 7,500. Check that out, that's pretty cool. A little tie-dye, right? Very cool. So you see the process adjusting in real time to these changes, because it's not like we just drain the barrel, right, and then put in a 25 melt. So not only did we not go that far, no process adjustments, but we're also seeing the transition in between, right? So we're going from 11 melt to 25, but we're also getting all the MFIs in between, right, as this material pushes through. No touches, right? As an old mold tech, I don't have to touch this machine, and you can throw whatever you want into it and it runs well. I mean, conventional molding is get a good repeatable machine, get good repeatable resin, get a good repeatable mold. Basically, the process audits the machine conventionally, where with Influx, it enables. So we've already shifted down to 13%. We're about completely through to this other MFI material. You'll see we still have some old material running through there. As that escapes the manifold, you might see this pressure set point settle in. So even though we don't draw the set point, our set point truly now is here, right? We like to keep a reference so you know where your original set point was. Now this works the opposite direction too. If we put in a 6 MFI or something incredibly hard to push like concrete, we've all run into that before, our pressure set point would rise. It's pretty hands-off, completely autonomous. I don't have to make any touches. It's good stuff. All right, so as you can see, we're completely done with this transition, and we've reduced now down 12% of our set point to adjust to the sustainable resin. Pretty amazing stuff. If you guys have any questions, throw them in the chat. We'll hit them later. But for now, I wanted to thank Yuki and JSW for supplying us with this awesome machine to do this demo on. And back to you, Ethan and Dale.
Thank you, Mitch and Yuki, for that incredible demo. I don't care how many times I see that. I still get excited, even being an Influx employee. I love innovation. I love new technologies. One of the things that I love most about that, even aside from the benefits of the Influx technology, is the JSW press, the intuitiveness of the controller.
Yeah. Yeah, one of the things, besides energy efficiency, JSW also recognizes the challenges in the workforce of having qualified technical people. And so what we've done is we've developed a control that is very intuitive. It's an icon-based control. So anybody who operates, if you know how to operate an Android phone, they can go down to that controller and recognize all of the different icons that we have in there and just go right through it. And there's even features that we have in the machine where it will walk the processor through the entire setup of the process phase when they're establishing a process for conventional molding. But by utilizing the Influx technology, it basically eliminates that, where the Influx system can do the adjustments on the fly real time by utilizing the melt pressure sensor feedback.
Yep. And you take an extremely intuitive machine and you put it together with an autonomous process that does a lot of the work for you, it really lends to productivity and getting up and running quickly and maintaining a sustainable process. We actually have some bonus content for you from that demo, things we didn't necessarily get to see out on the floor, and those are in two categories. We're going to see how Influx handles balance in the tool, yes, with the block cavity and why that works, but we're going to focus on that. And we're talking about tonnage reduction. We've talked a little bit about pressure reduction and what that means in tonnage, but we're going to show you on the mold that you just saw what those two things are. So first here we're going to show you is kind of a scatter plot of the weights of the cavities, conventional versus Influx. And what you're seeing here is conventionally, you are running a set, we've talked about this many times, running a set velocity to a set position every time. And in a tool, packaging tools especially, high cavities, hot runner tool, you are going to have imbalance naturally in that tool. And conventionally, your pressure is continuously climbing and climbing and climbing until you transfer. What that means is you are going to have that thermal imbalance, or maybe it's just from the design in the tool. You're going to get different parts. One part's going to feel faster than another. One's going to have more pressure than another. And what you get and what you're showing here is kind of these clusters of imbalance of part weights being unique. And what that's going to cause is different parts in production. Jump over to the Influx side, and what you're seeing is a lack of those clusters in the scatter plot. What that's showing in this case is that Influx doesn't care as much about that balance in the tool. It's the same reason we can block cavities and continue to run and still make good parts. Every part in that tool is experiencing the same pressure profile. If you block 8 cavities like we saw, the remaining cavities are going to see the exact same pressure profile. So even if one part fills out faster than another, that's not going to dictate a bad part. Our process is going to adjust, maintaining that constant pressure. The second thing we're going to show you is just on tonnage reduction. So what you see here conventionally is as you reduce the tonnage of the press, the clamping force that's holding that tool together, the parts are going to increase in weight, and eventually you're going to get flash because you're not holding the mold, so that plastic's starting to blow it open. And like you're going to get flash when you reduce the tonnage. With Influx, what you can see here is much less impact on part weight with that tonnage reduction and no flash on those parts. And that's because, again, the low constant pressure. We're not blowing that tool open. We're not forcing a lot of pressure to fill that part out. We're doing it at low constant pressure, which allows us to reduce tonnage, which is going to improve the wear and tear on the machine, on the mold, and we've talked many times, lower the amount of energy needed to clamp that part closed. And so that's just another benefit of Influx.
Yeah, and even to add on to that point, you take the density of each part. Now, in the example that we just showed, that's a 32 cavity mold. We run it at 4.7 second cycle. And by getting that part weight stable is critical by not overpacking it, because you think, oh, well, that's just, that's not very much material. But if you look at it times 32 cavities, 4.7 second cycle, you look at that over a year's time,
yeah,
that material savings is substantial.
Absolutely.
That's where it is critical. And that's, again, that leads to sustainability of the industry, where you're using less material and yet producing functional parts.
Yeah, that's perfect. So that's a great segue. Talking about like the real life, right? So we showed this demo, we showed some cool things that we can do in a lab. Dale, talk to us about how do we convert that into real life situations and how this brings sustainability to real customers.
Yeah, just by getting that part weight stabilized and knowing where, okay, this part meets our quality standards, let's lock it in there. And that's where the Influx system comes into play, where it is able to lock that and keep that process repeatable throughout the day, throughout the weeks, throughout the months.
And what other issues do the conventional world have with sustainability? There are a lot of limits that they have. You want to talk a little about that and how Influx and JSW together are solving those issues?
Sure. In the conventional injection molding process, there's a lot of fluctuation. If you think about it, the screw that is gathering the material to be injected into the mold, it's not an exact science. I mean, it's just a rotating auger that's pulling in these pellets, and that amount of pellets is not exact. There's variations in that, and with the Influx system, it basically limits those variations. It compensates for those variations, and it's able to overcome that real time as the process is running. That's one of the biggest benefits.
Yeah. And one thing that Mitch mentioned out on the floor that we haven't really talked a lot about is our feature called melt travel. And just to your point right there, in the conventional process, you're setting a RPM, speed, rotations per minute, and you're sucking back to a set position. You can have material inconsistencies, and especially when your machine starts to go and you get wear and tear on your check ring, the volume of material in every one of those shots is not the same. And then you're going to take that assumption that it is the same and try to put it into a set volume in the mold. We've already seen what happens when that volume changes. But in the injection unit itself, that can add a lot of issues in your part when you assume that that is stable. What melt travel does is, because we have our melt pressure transducer, or we call it our MPT, downstream of the check ring, we can ensure that the material has been compressed, that the check ring has been set, and with low constant pressure, as long as we have enough material, we don't really care what our shot size is set to, as long as we have enough. So we don't need a cavity pressure in the tool to do all these things we're talking about. We actually have a much more efficient way of measuring the position of the screw after it's already been compressed. And that's a key to what we do as well with AVA, monitoring the viscosity of the material. Another feature that allows us to enable more viscosity absorption, I'll call it, into the process, allow us to still make good parts. And so when you look at the JSW all-electric press, reducing energy, being more efficient, you look at Influx using things like auto viscosity adjust AVA to handle, in melt travel, to handle material changes, as well as what we do in the mold, that together is really what's bringing it, I think, for our customers partnered together to be able to gain those benefits. And in just a little bit, we're actually going to go to one of our mutual customers, AGS, which uses Influx on JSW presses to realize a lot of the benefits that we're talking about here, and using recycled material in a very cool way, which we'll talk more about that. But first, before we visit AGS, we want to talk about Sustainable Resins. Sustainable Resins is the company who actually gave us the material that we used in our demo. They are a company who delivers certified post-consumer recycle, or PCR. And what I love about Sustainable Resins is they don't just support material, they support resin suppliers, they support recyclers, and they service manufacturers as well as the producers of the resin. So they are another company that truly partners in innovation around sustainability. They're not a one-track company. They have a mission of sustainability, which is why we're so excited to partner with them. And with us remotely, we have Chaplin, the Director of Operations from Sustainable Resins. And we're just gonna ask Catherine a couple of questions and have her fill us in on some of the passion and drive and the goals of Sustainable Resins and what that looks like in the industry. Catherine, the first question I have for you is, a lot of us have heard about recycled material and recycled resin, even maybe post-consumer recycle, but what makes the resin that we use here in this demo unique to other resins?
Well, Ethan, this resin is comprised of over 85% recycled plastic, mostly derived from municipal curbside waste that would otherwise be destined for landfill. Essentially, it's your old, yogurt cups, sour cream containers, things along those lines that go through a sophisticated sortation and cleaning process, thus allowing the material to be reprocessed into new goods.
Well, I know how much my family uses sour cream. It's probably too much, but I'm glad to be helping the cause with my old sour cream containers. What are the biggest misconceptions generally about post-consumer and recycled material?
Well, Ethan, many equate post-consumer resins to, garbage or trash, which is a fair assumption, as a vast majority of it is mined from waste that has fulfilled its original intended use. So you think of the sour cream container. Sometimes it could be hard to get your mind around something like a sour cream container being transformed into a functional car part or personal care item, packaging component, whatever the case may be. The biggest misconception is that recycled resin plain and simply doesn't work, or it doesn't perform consistently, which we've been able to prove otherwise over the course of the last 20 years. The reality is that there are greater barriers to entry with recycled, especially if less than ideal applications are targeted. But I believe that that's really more of a reflection of lack of infrastructure, lack of recycling infrastructure here in North America, which is rapidly developing. In the meantime, through identifying the right applications that are suited for recycled resin, and also further developing compounders who have decades of experience with reclaimed material, PCR can absolutely be successful. And we've proved that within a variety of industries, as well as with a variety of brands and end users. The key to success is absolutely transparency between supplier and end user. You definitely have to expect collaboration. The material off the bat, realistically, will not run exactly the same as virgin. But, with some simple analysis, the formulation can, in many cases, be modestly tweaked for long-term viability. PCR can also be certified to authenticate the sources where it comes from, and also to ensure that it does not contain hazardous substances. And we at Sustainable Resins partner with a number of third-party entities to help end users reduce uncertainty of using PCR. At the end of the day, every pound of virgin resin saved is a step in the right direction.
Yeah, and Catherine, I think that misconception we talked a little bit about is kind of the struggle or limitation in the industry to using a lot of these innovations around resin suppliers. So thank you for clearing that up and giving us some guidance into that. What do you think, knowing some of those limitations that our customers may face and our partners may face, what do you think is the best path forward for organizations looking to expand on that a little bit and use more recycled resin?
Well, Ethan, I always recommend start small. Ask for help. There's a lot of industry experts out there who can help navigate these sort of unfamiliar waters. And it's okay to consider a gradual approach. Smaller percentages of post-consumer resin are still monumentally impactful to the environment. And it's okay to have a product that is comprised of, perhaps 50% recycled material. There's a lot of aggressive goals out there right now in terms of carbon footprint and sustainability. And it can be a little overwhelming, especially when the targets are, large operational investments, things like wind power, solar power. There's more, I think, modest steps in the direction of a sustainable future, even when you're looking at your materials. So, just having the mindset of a willingness to go away from fossil fuel derived materials that come from petrochemical to a recycled avenue is a big step. And, we can ramp up. Maybe a product starts with 50% recycled and we gradually increase that over time. You can start small and dip your toe in and still make a difference. We strive to be the conduit to market for recycled material because there really is no well-defined route currently in place. And we have over 20 years of experience positioning recycled material on unique applications, often with strict performance specifications. So we're open to challenges and we encourage you to challenge us.
I love that last piece about being open to challenges. I think that in showing some of these innovations are often born out of challenges, and I think that JSW and Influx would both agree that challenge is what makes us better. So I love that. Thank you, Catherine. How does Influx change your mindset about developing PCRs from a company like Sustainable Resins. What's your perspective on that?
Well, it's exciting because it speaks so much to the current concern over lack of recycling infrastructure here in the United States and North America. Development in this sector is evolving, but it takes some time as well as some significant monetary investment. And this is an innovative technology that still offers great economics to end users. In my opinion, I think it's a great catalyst to inspire change. And through Influx, PCR can be better positioned for immediate use in the now because it addresses so many of the processing concerns that can potentially arise when running this material.
Thank you, Catherine. Do you feel that resin flexibility, like wider specs or multiple sources or streams of that material, combined with an adaptive technology like Influx, would that ever allow PCR to become cost competitive with virgin material?
Absolutely. Not only in terms of dollars and cents on the material, but for ease and time for organizations who are transitioning materials. Many individuals and departments are involved in qualifying a new material, and not having to invest in new tooling is monumental when considering a material transition. Cost neutrality is pretty important, and businesses still operate with economics in mind. So innovation in this sector should always keep the economic element in mind to truly be successful.
Hey, Catherine, thank you for the information on the post-consumer resin. We really appreciate that because at JSW, again, we're very focused on sustainability. So some of the, with our R&D, that's one of the things that I really like about JSW is the research and development that we do into these sustainability technologies. We have done many tests with different types of bioresins, and one of the things with bioresins is that it kind of extends the cycle time, which really isn't very conducive to the injection molding industry because it's all about production and speed. So by lengthening the cycle, it's not a good thing. So we've developed systems with the bioresin because of the long cycle times, where we've actually utilized a mold changing system that when we injection mold a part, we can actually remove that mold during the cooling process, install another mold, and have that being processed while the other one is still in the cooling phase, and back and forth. So we utilize that wasted time to, again, increase productivity. That's what it's all about, especially in packaging. Some of the other things we're working on is our SoFit technology, which is lightweighting of parts. And we touched on it a little bit earlier about, you've got 32 cavities running at 4.7 second cycles. By reducing that part weight, it greatly increases productivity and uses less resources, which is what this is all about. So utilizing our foaming technology, which we call SoFit, we're injecting a gas into the material, which causes it to expand, and it lightweights the parts, but it also makes them more stable, and that combined with the Influx is basically unbeatable.
Yeah, that lightweighting is something that we haven't had a ton of chance to dive into, but because we are packing as we're filling during the Influx process, we're not slamming the material in there and then coming in the second phase and just leaning on the gate and sitting there trying to pack the whole part out. We're packing as we're filling. We don't have to pack all that material into the gate to try to fill out the end of the part. So Influx itself actually naturally reduces the weight as well, up to 3% sometimes in an average part. And that's just natural to the pack as you fill. And we actually have a couple images here that we can show that show you conventional versus Influx side by side, where conventionally you're used to seeing a short shot being bumpy and kind of have the orange peel or the golf balling effect because you'd have no pack, so that material is sinking away from the wall. The Influx short shot, however, and we give these out in our sample packs, but the Influx piece is fully packed out even though it's short, also reducing lightweight. And that's what I'm talking about with the partnership efforts in sustainability is we all have a common goal in mind of sustainability, of lightweighting of these things. And I think that this partnership with JSW, with Influx, with companies like Sustainable Resins, it takes that kind of partnership to really drive change in the industry, which is one of the things I'm most excited about.
Yeah. Yeah, and that's one of the great things. And if anyone is interested, you can request some of these samples and we'll get them out to you, because there's nothing better than visually looking at these samples that we have developed with Influx, and it really shows you what the benefits are. It's really easy to see once you see these parts. So anybody that needs any of this information, you could just reach out to us and we'll get, you know, whether it's on any of the JSW technologies that we have available or the Influx technology, we'll be able to get you whatever you need. In a moment, in this this relationship that we built with Influx, we had the added benefit of having one of our very good customers who is really interested in the Influx technology. It's very important to their business, and they helped to push us in this direction. But by doing that, we had the benefit of being able to work closely with that customer along with Influx and develop the interface, the communication between the two different controls, because basically we're allowing Influx to take over the control of our machine, which is difficult to do in many cases. But by having the partnerships we have, we're able to do that and successfully accomplish our goals. And Influx is very crucial to the AGS success.
Yep. And AGS, our mutual customer, has used both JSW and Influx, like Dale said, to, I think, the best of its advantage, and while also doing their own incredible goals for sustainability. And you'll see in just a moment how they took a unique spin on recycled resin that many people would think is impossible, using JSW and Influx to recognize those advantages. So our CTO, Gene Altonen here at Influx, actually had the opportunity to go recently to AGS, and he's gonna be there interviewing with them to show you not only their take and their goals and their efforts towards sustainability, but also how they've taken advantage of the JSW Influx partnership. So we're gonna take that away now.
All right, so I'm Gene Altonen, Chief Technology Officer for the Influx Company, and I'm here meeting today with George Stanulis and Chris Rosellis, the co-founders of AGS Technology. And so guys, AGS Technology, how long has AGS been around?
Well, it's 26 years already, hard to believe.
Wow, okay. Yeah, and I guess for us, for Influx, we've been working together since, I guess, 2019, 2018, back in that range?
Yeah, right after NPE, met you guys and got working together.
Yeah. So, and we've always found you guys, what you do here, to be impressive. You guys do some really unique things with regrind and turning them into high quality parts. And so, yeah, we're excited to go inside and see what's happening. Are you guys ready to go in?
Yeah, let's go.
All right,
Let's
thanks.
do it.
All right, so George, can you tell us a little bit about AGS in your business model and what you uniquely bring to the injection molding industry?
And I saw as an opportunity was, rather than looking down, is to look up, is to take this material and see how we could improve it, the recycled material. And so that was kind of the approach that we took, and we built data sheets around it to make the material very reproducible. And what we did then is we went after a much different marketplace. Typically the marketplace that existed kind of at that time, more or less, we called it the flower pot and fence post applications. And what we wanted to do is we wanted to go after higher end automotive, electronics, those types of applications. And so they were looking for consistent feedstock or suppliers, and that's how we position that company.
Right.
Chris and I thought that the way of addressing that was to basically to do the molding ourselves. So what we were doing then is basically providing our customers with a molded part that we would then certify met all their requirements.
So you certify the materials then against a performance standard, is that?
Right. With AGS, it's not that we're certifying the material, even though we can verify that the material does meet the specification, but more importantly, that their part meets their spec.
Excellent. And so you're, I mean, today, so you're taking regrind materials and you're not repelletizing, you're directly converting those into a high quality finished part that performs at a standard your customer is interested in.
That's correct there, and that particular model of what we call a direct injection molding of the recyclable was somewhat new. We were much more demanding, tight tolerances, that require material that had to be of a sufficient quality so that their part would last, like say in an automobile, was 200,000 miles back then. There, and so it's even much more now there. So there was quite basically a learning curve, and it involved some applications of some new technology that allowed us to deal with all the variations in the material, the different viscosities, different particle sizes, different melt characteristics, etc. And I guess that's what brought us together today, is to kind of talk about that a little bit later here.
All right. So now I'm here with Steve Versalis, the commercial manager here at AGS, and we're going to talk through what you guys do to procure materials and what you do with them once you get them here on the floor.
Sounds great.
All right. So you guys have been at this 26 years. Can't imagine how many millions of pounds of material that must, you guys have gone through in that 26-year period. But what's your approach? How do you go about sourcing materials?
Right. To answer your first question, I think we estimate that we're about 40 million pounds now.
Okay.
We find 6 to 7 million pounds a year of material, and then we, as we grow, that becomes our biggest challenge, is how do we do that? So the good thing is that George and Chris really had great relationships from their previous experience. They carried those over, and for the last 26 years have really formed great partnerships with people that know where waste streams are, have secured those waste streams, and are using those waste streams and diverting them to us.
I guess we could talk about what about the relationship with your customers. How do they, what journey do they go through in trying to, begin to buy parts using this unique approach?
Yeah, it's another good question. With our customers have to go through a journey of being educated, re-educated, because a lot of them are under the belief that regrind can't be used at 100%. And so there's this, George has always said that it's all about the specifications of the material and how the material can be used. And so whether it has, 1 heat history, 2 heat histories, you'll see that in the specifications of the material. So when we certify the material, it's certified that it will work in that specific end part.
And so those customers, have you found that as customers come along the journey with you, that they're repeat customers, your business grows with those customers?
Yeah, what we find is there's a lot of companies that we work with for many years that if you saw their chart of growth with us, it's very strong. So what we see is generally coming in some type of a blend of virgin material with regrind, kind of their comfort level. And then as time goes on, we see them remove the virgin material and go completely to our injecto blend, pure formulated material. And then you'll see them all of a sudden we'll start talking about new business and launch business and moving tools from other locations, because it's cost savings, it's environmentally friendly, and they really like the story of what AGS is doing.
Yeah. So Steve, walk me through then. What are the steps? That pellet or that regrind really lands on your dock and now it's got to go through your entire process to that high quality part that is going to that customer.
Yes.
What are those steps?
Yeah, so it really starts with these relationships with vendors. So we spend a lot of time working with our vendors. We're meeting with them quarterly. We'll walk their floors, see how they're getting their materials. We'll work that side of it. But once it comes into this plant, we'll spend time inspecting it. We then blend the material up. We will then test the material. And what we're really looking for is we're looking to certify it towards that end specification of that customer. But we will then mold and test and certify and then prepare. And that's really where the magic of AGS comes in, is we work on that formulation. So we are now being specific to that customer end part when we formulate. So we'll formulate material for that end part, and then we will injection mold that part, and then at the end we'll verify again. So there's multiple checkpoints in there where we're constantly testing, certifying our own material in-house to go into an end customer part.
This is really a solution on that material side of the equation that it's tough to find solutions to really drive down material cost.
Yeah, I agree with you wholeheartedly, and I'm surprised that we're not getting more people looking at this solution. I think it's that jump over that they've been trained. There's a certain amount of post-industrial regrind that's been formulated that can go into their end parts. And that's the paradigm we need to shift with our customers. Because once they get through that shift, they start sending us parts, and then, as you mentioned earlier, they just get comfortable and they grow with us.
Well, Steve, thank you. That was excellent to learn more about what you guys are up to, and good luck.
So Chris, tell me about the facility here.
Well, the facility, it's 80,000 square feet. We moved here in 2014, and it was originally a caps and enclosures facility. So the facility itself was built for injection molding, and we're actually walking across a tunnel right now that's underneath us that has all of the electricity, all of the water, and all of the compressed air to be able to service each machine. And it's really nice because from the tunnel, we can go a very short distance with electrical and the compressed air and the water to be able to service each machine. We've actually had machines delivered here on a Friday and had them running by Monday. That's how quick the connection has been. So we've been really fortunate with the facility itself in terms of how it was built.
You've got a lot of JSWs in this plant. Tell me about what makes JSW such a good choice for you guys at this site and for what you're doing.
Well, first, it's got an all-electric servo, which for us is important. We're actually not on the ComEd grid, we're on a Batavia grid. Our electricity is actually more expensive than other injection molders. So getting all our machines to be electric is a real priority, and JSW for years has had electric machines, which again have been workhorses from us. Benefits being, again, low electricity costs, very quiet machines, and very repeatable. We've had excellent repeatability. And then, of course, what's also great is the fact that now they're so well integrated with Influx. And that's been a real seamless process for us to be able to either retrofit the machines that we had that were electric, or with the new machines, having it already integrated with Influx.
So, Chris, here you've got the Influx system installed, and you've got your HMI here adjacent to the JSW HMI in this particular configuration. But tell me, how has Influx helped this operation run more efficiently? What are the benefits you're seeing from running Influx?
Well, the big benefit is definitely the fact that with regrind we have different viscosities, whether it's lot to lot, shot to shot, or even within the shot. And the low constant pressure, what it does is allows us to mold versus conventional molding and just be able to be more consistent and make a more consistent part. So the part quality is improved, we have less scrap, and that translates into more uptime. And all of our metrics with the Influx at this point show that type of result.
Excellent. Now, are you seeing aesthetic advantages in the part? Does the part look better? Is there less sink, less warp? I mean, are those things that you're seeing?
Definitely. We see a lot less sinks in the part. because you're packing the part as you fill. So a lot less sinks, a lot less molded in stress. So we get better dimensional stability. And then we actually see there's some parts that we mold that have important weld line strength issues. And with the Influx, we've been seeing through the testing of our customer some significant improvements on weld line strength. So that's been a real positive as well. The second thing is recycled materials are just more volatile than virgin material.
Right.
So what we found was because the screw speed is slower, is we don't see splay or burns as much as we do with using conventional process. Right. Another big benefit. And then finally from that, we do use a lot of subgates and and a lot of glass reinforced materials, and we're just seeing a lot of improvement in terms of the subgates not seeing that same wear and tear with the glass, again, because we're going in a much lower shear rate.
Yep, excellent. What about dimensionally on the parts? I mean, maybe dimensionally more stable from a warp standpoint, but what about just from an overall consistency of dimension standpoint? Are you seeing better consistency?
Well, for sure. I mean, our biggest issues were flashing short.
Yeah.
And we had a lot of detection in place to be able to find that. We're seeing a big drop off in flashing short. And then when we take parts into our lab and we measure them, we're just seeing a lot better process capability for some of the items we measure with variable gauges, overall length or critical dimensions. We're seeing a big improvement there as well.
Here you're molding, this part is
yeah, it's a what we call a functional black plastic part. It's used in the chassis suspension. This part is very high volume. It's used in trucks and SUVs. And it's actually got some very thick sections in it. So when we originally designed this mold, we had to design it conventionally, but we definitely had Influx in mind. So the first step was going to be an 8-cavity mold, but we knew we could sneak in another 2 cavities.
Right.
So now we could go from an 8 to a 10, and that obviously had a big impact on piece part price in terms of driving it down. The big concern is lower tonnage. So here with Influx, what we've seen like a 50% reduction in tonnage. And that gives us a lot of confidence to take jobs that would ordinarily run in a 1,000-ton machine and be able to run it more in our 720-ton machine class.
So Chris, tell me about our Influx team. How's our team been to work with?
Well, the team's been great. Everybody we've worked with, we found to be extremely knowledgeable, motivated, and really personable. We've sent actually a lot of people to your headquarters in Hamilton, Ohio for that 4-day intensive training. Right. And when they've come back with just a great foundation about Influx and what needs to be done. And we've actually followed that up with on-site training that Influx has supported with different personnel. Also in Spanish, because we do have Spanish-speaking process techs that their native language allows them to get that really in-depth knowledge of Influx by being here, working on our equipment, our molds. So that's been really great. And then on top of it, a lot of the training aids in terms of the spreadsheets to help calculate high and low, and then also the training aids to be able to do some troubleshooting have been really, really helpful. So the support we've gotten from the beginning to current has been really, really excellent.
Now I'd like to introduce Mercedes Landazeri, Technical Director of Peacock Colors and Plastic SPI sponsored podcast. Mercedes, tell us a little bit about Peacock Colors.
Thanks. So, yes, Peacock Colors is a company that makes plastics color, also color for thermosets. We're located in Addison, Illinois, and we also have a liquid color plant up in Sheboygan, Wisconsin. So I've been with them only since February. I was brought on to drive innovation. So when I initially found out about the Fearless Innovation Series, it was through, as you mentioned, the Plastics podcast that I run with Lindsay Nepple. And we were invited to come host this Q&A session last time. But my ears really perk up when I heard the innovation word, and I wanted to get involved with Influx and JSW on this project for color. So that's why I'm here. Thank you so much for having me.
Thanks for being here, Mercedes, and coming back a second time. You must have liked something about what we're doing here to come back, so thank you. Before we get started in the Q&A portion, I just want to do a little housekeeping. Stay tuned at the end. We're going to actually go back to Gene. He's going to talk Influx and sustainability, and we're also going to have a live booth Q&A. So if you have any other questions that we don't quite get to in this portion of the Q&A, I will be at a booth afterwards, so keep your questions then, and we'll handle that. And Also, we're going to have a couple polls pop up during this portion of it as well. So if you don't mind taking a couple minutes just to go in there and answer a couple survey questions, let us know how we're doing and how we can improve these innovation series for the next time. Before we start into kind of the broad Q&A, I'm actually going to ask you a couple questions, Mercedes, if that's okay. One of them, we talked a lot about the challenges that the industry faces with sustainability. What are some of the challenges uniquely from your perspective that Peacock might change in coloring those post-consumer recycled resins?
Yeah, that's a great question, Ethan. So, interestingly enough, some of the issues that we face, some of the challenges that we face in coloring plastics, recycled plastics, or biocomposites, are really similar to the ones that we experienced at the beginning of the plastics industry, which is the uniformity of material in dealing with that. So, quick analogy here: if you have printed out just on a color printer a picture on a white sheet of paper and then printed it out on a gray piece of paper, that picture is not going to look the same. The colors are going to be really different. So it's going to, and it has nothing to do with the actual colors of the ink or toner, right? It has everything to do with the base material. So it's really important that your color matcher, that your color house is coming from understanding where the starting point is, and it's really helpful to get just a few pounds of that recycled resin, that PCR, PIR, or other sustainable material. The other thing is the issue is overcoming all the other colors that are already in the recycled material and additives. So with master batch, sometimes you have to go up to a much higher letdown ratio than traditionally. You might have to go up to 6%, 10%. I've even seen like 20% to achieve a specific color. And actually, this is really where liquid color has an advantage, where you can still achieve, I think for this project, to hit the JSW blue and the recycled resin, whereas our master batch, we had to go up to 6%. Our liquid color house can achieve it at 2%. So actually, pop into our booth at 2 p.m. And our other technical director on the liquid side is going to be giving a presentation about that.
Right. And yeah, the material supplied by sustainable resins, you saw the color change happen from the JSW blue kind of the Influx green. That color was supplied by Peacock Color, so thanks for doing that. Shows our AVA and material transition really well, and as well as looks really cool. So we have that.
So now it's my turn to ask the questions. Turning the tables here. So, so Dale, this is a question from a high-speed packaging molder. And if you have questions, please type them into the chat here. So from this high-speed packaging molder, will this increase my cycle time with the low-pressure molding?
Well, it does give that. It does initially, if you think about it, it does give that impression. If you hear low pressure molding, you immediately think slow. But the difference is with the Influx system, what it's doing is it's actually packing as it fills. So you're basically, it's doing it in a couple ways. It's going to reduce your cycle time. You're eliminating the holding phase of the cycle because it's packing as you're filling, so there's no need for holding. And also, you're not introducing all of the additional shear heat of the high-speed filling. So you're putting less heat in, so you don't need as much cooling time either. So it speeds up the cycle, actually. Does the opposite.
Great. And a question from the chat. Why can't I just do the same thing as Influx with my standard IMM, utilizing hydraulic pressure?
Yeah, so I'll take this one. We get this one a lot. And I think Gene actually talked about this a little bit in the intro, but if you didn't get a chance to see that, I'll kind of break it down. First and foremost, we utilize a melt pressure transducer, and it's downstream of the check ring, and it is just not the same thing as hydraulic pressure. A lot of people think that it would be. It's not. There are a lot of compression differences, lag differences between a hydraulic pressure and a melt pressure. And if you look at a constant hydraulic pressure, your melt pressure is actually going to be varying, which is what we don't want. We want that constant melt pressure. So just in that right there, there's a huge difference between that, and that's even if you have hydraulic pressure. You could have a load cell or something like that. So there's differences there. Another big difference is our tuning. So the conventional IMMs, they kind of do one standard tuning. You might have like a high, medium, and low kind of tuning range, but that's kind of what you get for that machine. And that's going to be true no matter what mold you put into it, no matter what material you put into it. And with Influx, we actually have the unique ability to tune to a system, meaning an injection molding machine, a mold, and a material uniquely. So every time we set up a process, we retune it. And what that allows us to do is fine-tune, no pun intended, the response optimization of that material and in that mold. So we react, we talked about this throughout kind of this whole day, how Influx responds is that constant pressure, we react to variations in the material and in the mold. So geometry changes, things like that. So it's imperative that we can respond very quickly and appropriately without kind of overshooting, undershooting, those kinds of responses, which can happen if you just use kind of one set tuning parameter for that system, and that's going to cause hesitation. And we kind of talked about, you just mentioned this, there's a misconception where low constant pressure would mean that it might be a slower cycle time. There's also that it might mean hesitation, but that's the key. We have that tuning, we have melt pressure transducer downstream of the check ring. We're seeing exactly what's happening and responding real time to prevent things like hesitation, and part of that is the tuning. So those are just a couple of reasons why it's just not going to be the same reaction time or response, let alone our innovative technologies like auto viscosity adjust, which we see in the demo, and response to cavity pressure or melt travel end of fill. So kind of all those things together are why you can't do the same thing with your native IMM as you can with the Influx technology. That's a great question. We get that one quite a bit. So,
Ethan, thank you so much for that pun. As you know, I love a good pun. Keep them coming. Also, feel free to add puns in the questions. You get some bonus points for that from me. So you mentioned low constant pressure, which many of us feel in our personal lives. How is the pressure set point for a part chosen?
Yeah, another great question. We have a unique range finding system, which is called LECR, the largest empty corner rectangle, which is really just a math term for finding in a polygon made up of no shorts and no flash. We look at different pressures and we look at different times. It's very simple. And we can kind of find this polygon that makes an aesthetically good-looking part. And then we use this LECR to find the largest processing window centered inside of that. And from there, we do a very extensive DOE, a response surface DOE, which allows us to take points both inside that kind of polygon and some kind of axial points to get a really good picture of all of the pressure and time ranges within a system to find not only the most centered part, but the one that makes the best part dimensionally, quality, aesthetics, those kinds of things. And then on top of that, you have the AVA technology and other pieces of Influx that are working. Not only do we have a bigger, more centered process, we also have technologies working to real time drive that back to center. So the process itself is going to be more stable just naturally, as well as these technologies that as variation comes in and tries to drive you out, we can center that. In that process, we teach, we may talk about this a little bit more later, but in our training, which will teach our customers how to find that validated process and then use the technologies on top of that to drive it back to that.
Another question here from the chat, which I identify with. So what is the learning curve from switching from conventional to Influx? I mean, I've only been molding, as you know, for injection molding for a few years. I feel like I'm finally getting good at it. This is a really exciting technology for me to hear about, but how difficult would it be for me to switch to it?
I'll let you answer this one, Dale, because you're not from Influx, but you've done the training, so I'll let you answer this question.
Actually, it helps because you could use the conventional process as your starting point and then transfer it over to the Influx system and then just let the Influx take it over, and you'll see what the differences are, how it becomes autonomous to, adjust to the changes in the viscosities. You can go from a 30 melt down to a 6 melt, and the machine will be able to correct for that.
And Dale, you and Yuki helped us out with the demo out there. Yep. You both went through our training. That's kind of the experience you had with it. Talk a little bit about how, was it easy to grasp? Sometimes, you had that industry knowledge. Some people have been doing it for 30 years, 40 years, and they come in. How was that for you as far as the, was it simple? Was it, kind of, what was that piece of it for you? How was that switchover mentality?
There is the little... Initially, you have that little bit of hesitation because of something that's so ingrained to you for so many years. But once you break through that shell, then it just flows like anything else, and it just clicks, and you get it, and you understand what the goal is, and you just go with it from that point. And even, you know, there's companies like AMD, American Injection Molding Institute, that does a lot of your training.
Yep.
They were very big for many years doing the scientific molding principles, and now they're teaching the Influx. So, you know, they do both, and it is, you know, easy to switch between them once you do understand what the goal is.
I'm glad to hear you say that. I went to Fair State University, go Bulldogs, and they, along with many other, you know, universities in injection molding, are now even teaching the Influx technology. And so I think that we find that's true. One of my favorite things was our professor actually reached back out and said, I have to change my tests because of Influx, because every answer that I give someone, like, how do you fix this, how do you do that, they just say use Influx. So I thought that was kind of a fun thing.
So it's kind of like autocorrect or like a spell check.
Yeah, exactly. Still me had to change its quizzes, so that's kind of cool.
That's good. Also, I did catch your, I don't know if it was purposeful or accidental, the pun about flowing.
Yeah.
Yeah. So how would this apply to a customer whose entire plant has developed all of their processes using scientific molding principles?
That's going to be you.
Yeah, so I think to your point, though, there is a little bit of a culture change with something that, especially, you know, scientific molding, you have these experts in their plant that are building all these things. But what that means is they know how to do something right. They know what the intentionality and the upfront steps to find the right process and validate it, and how important that is in your process. So once, like you said, once you can get past the thought change, it is a bit of a paradigm shift, but it's very easy to pick up. It's basically, we've said this multiple times today, it's a pressure for a period of time, and the technology takes care of the rest. So it is very intuitive. It is building towards closer and closer on the journey to full autonomous molding. So that startup is there, but also, like I mentioned, we use a very scientific approach to finding our validated process, and we teach that. So it is a bit of a culture change, but we just start somewhere. We kind of like to start with a few machines in a plant to get through the training, to get some hands-on experience. And then what's nice about our technology, it's very copy and paste. So we looked at the down cavities, right? We went from 32 cavities down, you know, blocked off 8, made the same parts. The same can be true on the other side. So you can start with like a prototype tool and build your constant pressure process for that geometry, and then scale up with the same profile very easily. So scaling across companies is very easy. Once you kind of get the concept of what Influx does, and it is different than what, you know, the industry's been doing for the last 60 years, I think the change is very fast. And what our customers find is, once they start down that process, it's very hard to go back to conventional, because this autonomy solves a lot of those issues that they've been dealing with for so long that kind of once you get it, you get it. And so I think that's that scientific background of setting up the right process, but in a way that's much more easy and intuitive and automated, helps with that transition pretty easily, actually.
And it's scary to get out of your comfort zone, right? But that's really the only time that we grow. I mean, one thing that was coming to mind as you were saying that, and maybe I mentioned this last time, but it's a great, it was like it turned on the light for innovation for me, was Jack Welch, the former CEO of GE, before they, you know, divested that to Sabic. He had said that, you know, if a company doesn't innovate at the same speed internally or outpacing the external speed of progress, it's destined for failure. Like it's not long for this world. So yes, we've done the same thing, you know, the same way for the past 60 years, and it's really important to realize that the world around us is changing, and we need to step up and challenge ourselves to change with it.
Yeah, I think that's what's so important about things like this, you know, this experience of this innovation series. We call it an innovation series. I almost like to think of more of a partner series, because we're partnering with JSW, with Peacock Colors, with sustainable resins. We know that innovation can't make real change just by itself. So that's why I appreciate so much the partnership of all these different companies coming together for a common goal, which in this case is sustainability. So I love that.
Are there any advantages if you design your molds specifically for Influx?
Yeah, I would say there's two parts to this question. Do you have to design your mold specifically for Influx? No, you don't have to. There are benefits to doing that. We've looked at things like, even Chris from AGS mentioned, they went from 8 cavities to 10. And that's even, we think about 10 cavities, that's a weird number because it's not balanced. And at the end of the day, it's all about balance. And we don't care as much about balance. So you can do things like upcavitate. We also, without no hesitation, you can reduce runner sizes, do longer L over T's, thin walls, things that sometimes we work with a lot of third-party mold designers. If we just handed them an Influx design without telling, they'd be like, "That's impossible. You can't do that. You can't mold that." So there are things we can do. We call it innovate or designing with Influx in mind. So we can do a lot of things that kind of further harness the Influx technology, but we don't have to. We can 90+% of what we do is on existing molds, existing machines, just with our technology enabling that. So, great question. If you guys let us know if you can see the polls on there, the surveys, and jump on and do those. And just kind of jump in the chat. If you've seen them, say, yeah, we got them, we're doing them, just so we know that they're working and that they're in there.
Are there any materials that Influx does not work on?
Another great question. There are some categories where we haven't done a whole lot of investigation into. And I think Brandon Birchmeyer even mentioned this in our last innovation series. Things like PET preforms. It's kind of an animal all in itself. We've dabbled, but not really dove into that head first. There's not really anything that Influx doesn't work on, and the reason for that, it's not an application technology. It's a new way. We say it often, a new way to injection mold. It's a different way to do it. So if you can injection mold it, we can do it. We can do this technology, or you can do it with this technology better. But there are some areas where we haven't spent a lot of time, really diving into and spending things like, we get the question a lot, LCPs, haven't had just the opportunity really to investigate, into that. And so for Influx, there aren't that many that Influx can't do, but I do know there are a lot of things that the customer struggle with that they can't do today, and Influx is a good, piece of that. And another kind of along the same lines, kind of back to Peacock, what are some of the things that, customers a lot of times struggle with, even just sustainable resins, let alone these kind of out there materials. They struggle just using recycled. So what are the ways that like Peacock and companies like that can do with color to enhance those recycled resins or things that they might have issues with? Yeah,
I mean, that's a great question, and it goes back to what you were just saying, Ethan, and also what Catherine Chaplin had mentioned, from the woman from Sustainable Resins who was talking. It really all comes down to closer partnerships within the value chain, and transparency with that is key. A lot of the color houses, these color manufacturers now, even some of the smaller ones, like Peacock is for the time being, right? We're growing, but we do a lot more beyond just color. But you won't know unless you give us all of the information from the outset. And so I would say really it's key to, the sooner and the more holistically you can articulate whatever that North Star is for your project or your product, the more you're going to get out of all of your partners, right? I mean, there are a ton of things that a lot of people who work with color do, providing additives like recycle stabilizers, odor control, and then thinking about, with end of use, near IR blacks and other colors for better recycling post-use. And beyond that, I mean, a lot of the really forward-thinking color companies now are hiring people like me who do trend forecasting. So you might not have come to, or even some of your customers might not have come to a smaller color house in the past to ask, hey, what's the next big color in 2022, 2023 going to be? But you come to Peacock or Vortex now, and it's like, we can tell you, we can help you out with this, and it's all about innovation. You have to innovate, and if you want your company to continue on long term.
Yeah, I think that's a great point, full circle to the original question too, is if you have questions about advancing sustainable materials, we've heard from Catherine at Sustainable Resins, jump in the chat. If you have a question, if you want to connect with them about questions about sustainable materials, recycling, or about coloring those materials, or if you have a material that you want to see if Influx will work with, reach out to us. We've done pretty much anything and everything you can think of. Like I said, there are a couple branches of odd things out there that we just haven't had the opportunity, but we'd love to. We'd love to partner and innovate in those spaces as well. So feel free to ask those questions in the chat for any of us here. JSW, we've talked a little bit about some of their innovations in those spaces. So if you have questions, feel free to reach out.
Yeah, we've all had crazy experiences. Actually, behind the scenes here, we were just talking about how my company last week was molding some hair compounds, about 10% human hair going into the color. Pretty wild sustainability projects that exist. So has Influx had any success with LSR?
And that goes to, again, I think that's one of the ones we just haven't really had the opportunity. It's a pretty short answer. We haven't had a ton of opportunity to dive into that. My stance is it's a replacement for traditional injection molding. So if you can do it today, and even if you can't, if you have struggles because of changing viscosities or high pressures or things like that, that's where Influx is built for. So yeah, feel free to reach out and maybe we can partner in that space. These are great questions. Thank you, everyone, for posting those. If we haven't got to your question yet, don't worry. I'm going to stay after, during Gene's next bit on Influx and sustainability, and a little bit after that in a booth to answer more Q&A questions. So if you have more, please just dump them into the Q&A chat. It's actually one of the expo booths. It says Q&A continued. So we can dive that. And Mercedes, you have another booth as well that's continuing on.
Yeah, in the expo part, if you want to hop into the Peacock booth at 2 p.m. Eastern time, our other technical director on the liquid side is going to give a great presentation about why liquid color is the most sustainable solution for coloring recycled plastics. 2 p.m. Thanks, guys.
And just to add in here, how this, another part of how this came about is, as everyone is well aware, NPE was canceled this year due to the pandemic. So this cell that we were running down there, that packaging machine with that, the 32 cavity mold, that was designed, that was supposed to be running in our booth at NPE with the Influx system. But unfortunately, we're unable to do that. We also had some other sustainable projects we were going to be running there. We're going to be running some biodegradable resin with a mold changing system that I had talked about earlier. So, you know, due to the pandemic, we're making do with what we've got, and this is a great way to do it. I hope everybody enjoyed the presentations and look forward to your questions.
Yeah, thank you. Just as kind of a wrap up here before we go to Gene. Thank you, Mercedes from Peacock Color. Thank you, Catherine from Sustainable Resins. And Dale, we got to work a lot together recently and with Yuki. Thanks for being here.
Sure.
We like to say that we make the impossible possible here at Influx. That doesn't happen without partnerships, which is why we wanted to bring kind of NPE to you. We didn't want that to stop us. So you have material color suppliers and sustainable material suppliers. You have OEMs that and our technology, Influx, and we all have a common goal. It's right now it's a big push on sustainability and innovation in that space in the industry, and I think that is all what this innovation series is about. Is that partnership in innovation and sustainability. So thank you for being here and for the time that we get to bring that to you. And now we're going to go to Gene, who's going to talk a little bit more about sustainability and Influx and what that looks like. And again, feel free to join Peacock's booth, check out the other booths afterwards, and also join me for some more Q&A if you have any questions that haven't been answered. Thank you.
All right, well, we're getting ready to wrap up, but before we wrap up, we wanted to dig just a little bit deeper into the topic of sustainability. You may have noticed today that there's been a big focus on sustainability throughout all the presentations. And I think that there's a focus on that for a big reason, and that is that as an industry, this is a big need that we're all focused on finding solutions that can help us deliver the ability to have a more sustainable, circular supply chain for plastics. And this is an area where Influx has big advantages, as well as some of the partners that have joined us today, JSW, Sustainable Resins, AGS. These are all companies that really specialize in this space and bringing efficiency and the ability to run sustainable polymers. And so we wanted to spend just a little bit more time talking about how all those things work together, to provide advantages. And so let's go ahead and get started. There are really three main drivers of value for Influx. One is improving your ability to run sustainable materials. The second is to use less energy and have less wear and waste in your system. And the third is helping you run lighter parts. And I'll talk about each of these. So to begin with, I thought I'd just step back and look at what's the challenge in running sustainable materials, and specifically PCR materials. And the challenge with these materials are they vary. And so what I've got here is three post-consumer recycled materials, all of them polypropylene, that we've run in a recent study here at Influx. And what you can see is we've got a nominal 10 melt, a nominal 20 melt, and a nominal 45 melt material, and each of them varied about 25%, plus minus 25%. So you can imagine if you're running an injection molding operation, managing that kind of variation can be a real struggle. It can require a lot of operator intervention. It can cause a lot of downtime and a lot of issues in your operation. The other thing to recognize when we're running PCR materials is you get batch to batch variation. And so, while I don't have multiple batches of each of these materials, you can get a feel for how much these might vary by comparing the nominal MFI to the measured MFI throughout this study. And you can see we varied from, I guess, about plus 8% to minus 17% in the case of the 45 melt material. So if that next batch comes in of that 45 melt material and it's on target, you got a 17% variation built in right there. So again, these are things that your process has to be able to manage during production. So, and this is where Influx really shines, because what we have is we have auto viscosity adjust. And you may have seen this demonstration in other places, but what we're doing here is going from a virgin polypropylene material and we're blending in a recycled material that's a much higher melt. I think we start with a 6 melt material in this case and go all the way up to about a 40 or 45 melt material. And you can see what's happening there is that our system is able to run through that transition from 6 to 45, and we do even bigger variations than that. And it's able to do that with no operator touches, no manual intervention. It's just doing that automatically. So the material is changing, the process is changing too, to keep your part consistent. That's really what's happening here with Influx. So you might also ask, is this real? You know, is it really necessary to be able to control between a 6 melt and a 35 melt? And I'll say a couple things. One, what AGS does in their operation, this is absolutely real. They're doing something very unique at AGS, and they're taking raw recycled material and they're converting that into a high quality part. So this is a wonderful solution for an operation like that. I think the other way to think about this is that the more variation your process can handle, the easier it gets for a company like Sustainable Resins to provide you a spec that is going to run down your line efficiently. And as they said in their part of the demonstration today, that saves money. There's no question that the narrower you need to make a spec to run in a given system, that adds cost to the material. So the wider you can handle, definitely you have opportunities there to save money in resin cost. So the other thing you need to know about Influx is a low shear process. And so managing variation is what's really important to a post-consumer recycled material. But you also have bio-derived materials and many different materials that are made from a more sustainable feedstock. Those materials sometimes can be shear sensitive. And so what you see here is a comparison between a conventional part. In this case, it's a flip-top closure. I believe that's for a hard surface cleaner, if I'm not mistaken. But you can see how high the shear is in the hinge area and in the gate area in this part. And you can see how much lower the shear is in an Influx part. That lower shear is critically important when you're running a material that is shear sensitive. This also is one of the things that helps us with running at lower melt temperatures and other things, because many of those materials are also heat sensitive. So Influx can have big advantages when you're trying to run some of those sustainable resins. So the next area to talk about is lower energy. And so Influx is a technology where you can actually get about a 20% lower energy usage from Influx when compared with conventional. You get that from lower clamping energy, you get it from lower tonnage machines is another way that, that we can derive a lot of energy savings. And you can get more output for every energy dollar that you put into your operation. All those things become very impactful with Influx. And so, you know, to kind of break those down one at a time, when we talk about filling, we're filling at lower pressures, we're moving the material in more efficiently, we're using less energy to do that. Basically, lower pressure equals less work equals lower energy use. Same thing with clamping. If I'm using half the pressure, I need half the clamp tonnage. So, you know, so these are both areas where I can save a lot of energy. And then when you combine that, so if this is a total cycle, this is where I'm putting work into filling a part, I'm going to get that lower energy from less clamp tonnage buildup. I'm going to get lower energy from less filling energy to fill the part. I'm going to use less energy in the packing and holding phase. And importantly, I'm going to run at a faster cycle. So, you know, one of the more traditional benefits of Influx is the ability to run at a faster cycle. That faster cycle actually leads to a much more energy efficient process as well. You're basically getting more parts out for every energy unit that you're using. So, and you might also be wondering, well, how does this differ between, you know, say an old hydraulic press that uses a lot of energy and a more modern press, like the press you saw in the demo today with JSW, you know, a very highly efficient, highly energy efficient press. And, you know, what you'll see is, yes, the area under these curves will get smaller. You're using less energy. But the bottom line is, while these curves may get lower, the area under the curve may get a little smaller, on a percentage basis, we still see energy reductions that look very much the same, whether it's a very inefficient press or it's a very highly efficient press. So when you combine all those energy saving steps together, you can achieve things like 22% energy reduction, which is what we're showing here on this is a deodorant cap example. But what we're doing is we're actually showing how these things stack. So, you know, if you just were to reduce melt temperature, which you can do with Influx, you can run lower energy. The Influx base process here, about 10% energy reduction. But these things build all the way through as you add clamp reduction and that cycle time advantage that we talked about. In this case, you can build to about a 20% energy reduction, 22% in this case. That's pretty typical of what we see in parts. Sometimes it's not quite that high. It can be more energy reduction than that. But this would be a pretty typical energy savings, certainly for these types of parts. So in the last area I want to talk about is reducing the weight of a part. And there's a couple of ways Influx can really be advantageous here. The first is, because of the way we fill, because we pack as we fill, we actually make a slightly lighter part, about 1 to 3% lighter. That is not a huge number, 1 to 3%, but it's a number that is very meaningful, and I'll talk more about that here in a minute. You also can redesign parts, and by redesigning parts, by taking advantage of the lower pressures with Influx, you're actually able to redesign parts to take advantage of that thin wall to take weight out of the part. So why do we mold a lighter part? Basically, we pack as we fill. That's one key area. The other is that we have a much lower pressure differential from gate to end to fill. So here in this case of a toothpaste cap, what you're seeing is conventionally, you have a very high pressure drop between the gate side of this living hinge and the other side of that living hinge, or the other side of the part. What you see with Influx is a much more consistent pressure gradient gate to end to fill. That more consistent or lower pressure drop across that part allows us to pack effectively everywhere into the part, even out these areas that are at the ends of fill, without overpacking back by the gate. And so we don't have a need to stand on that gate with a lot of extra pressure to get adequate packing out at the end to fill. And so as a result of that, we're able to hit all your critical dimensions and lower part weight. And again, about 1 to 3% is typically what we may see in a part like this, but really that's pretty common to see across really virtually, in any part type. So when we talk about reducing part weight with Influx, we're running at lower pressures. Because we're running at lower pressures, we can reinvest some of that lower pressure to redesign our parts to be thinner. And even though when we redesign the parts to be thinner, it's going to take a little more pressure to fill those parts, because we start at such a low pressure set point, let's say we start at half the pressure, we can thin wall that part a lot before we begin to see pressures build back up to pressures that might be more typical of a conventional process. So what you see here is the lightweighting potential on 3 parts. So you've got a flip top closure, you've got a Swiffer component, you've got a dosing cup, and what you see is the advantage here can be different across these various part types, but it can be quite substantial. You see a 25% potential here on the flip top, you see about a 35% potential here on the Swiffer component, you see about a 5% potential there on the dose cup. So, what do we typically see? If your pressures can be lower, if you can run at, a third less pressure, or half the pressure, and so on, you're going to see numbers that are, in this 20 to 30% range, let's say. If you're in a thinner part and maybe your pressure reductions aren't quite as low with Influx, you're not going to be able to thin wall that part quite as much, but you can still see things like 5 or 10% and even quite thin parts, say 3/4 of a millimeter or even thinner, really 1/2 millimeter and even thinner. So why does all this matter? It matters because if you take a typical factory, not a big factory, a pretty modest sized factory, you may run about 10,000 tons of plastic through that operation. And a 10,000 ton operation, reducing your part weight by say 2%, 200 tons. And for perspective, what's 200 tons of plastic look like? A rail car is about 150 tons. So this is a lot of plastic that you're not paying for, and you're taking that out of a landfill down the road. Similarly, if you're able to redesign a part, take 25% of that material out, not hard math, but 2,500 tons of material. You're pulling that out of a landfill, you're saving that money. And then if you just think about it from a recycle standpoint, if I can take this site, I can convert them over to 100% post-consumer recycle, I've just taken 10,000 tons of material out of a landfill. So these numbers are not insignificant. They become very big very fast, especially as this type of a technology or these kinds of contributions happen across the industry. So very, very big impacts are possible here. So in summary, Influx, it's a greener process, big sustainability advantages, the ones I listed, right? Run sustainable materials, lower your energy use, make lighter parts, big impact. Without the trade-offs, a lot of the technologies you choose to try to run recycled materials, there's trade-offs that typically occur with some of those choices. I mean, just running PCR, trying to run a highly variable material into a traditional type process, which is a static process, there are lots of trade-offs with trying to do that, and even some of the technologies you can apply there have their own challenges. A better way to mold. This is, you can get these sustainability advantages. You don't have the trade-offs, and better yet, you have real advantages. So the things that we talk about over time around, running lower cycle times, having lower pressures, better quality, all those things still apply here. So, you're getting your benefits of, moving to a more sustainable operation, and you're doing it in a way where not only are you not having painful trade-offs, you're getting some real advantages out of the technology that you're using. All right, so it's time to wrap up. And I want to thank everyone online for joining our event today. And definitely want to say thank you to all of our partners who participated with us today. So JSW, Sustainable Resins, AGS, and Peacock Polymers all played a role in today's event. And I'd like to invite you to stick around and participate in our booths and additional question and answer. Our team will be available all the way up until about 2:30 when the event will close. And our booths do include our partners today. So JSW, AGS, Sustainable Resins, and Peacock Colors are all available as well. So please take a look at their booths and chat with them as well. And again, I'd like to thank you, and that's a wrap.